What is happening?
Okay, all right, listen up here. All right, now the issue with some of you is that absences, and I know when you're getting quarantined, so you can't help that, but you gotta make sure you try and stay up as much as you can, and that's gonna be that's the biggest factor, is kind of attendance, it seems to be. If you're here, you do well. When you're not here, it's just you get behind, and it's hard to catch up. So, everything you can, make sure you try and get here when you're not here.
I'm always getting it.
So when you're not here, you got to get on Canvas. You got to follow through there. Okay, the expectation. All right, what we did on Friday, you didn't have homework. Christian, put that away.
My bad.
But let me just kind of go through here. If I got x minus 2y equals 1, and I got 3x plus 2y equals 19. Okay. There are multiple ways we can graph it. We can do substitution. We do elimination based upon the problem, based upon which method works easiest.
4x plus 20.
This one here is what we call elimination.
Or, no, 4x is equal to 20.
You're right. Because if you have this lined up, if we can get something to add up to 0, we can add these together and it stays equal. So like Jordan said, x plus 3x is 4x. Negative 2y plus 2y is 0 equals 1 plus 19, which is 20. I divide by 4, I get x equals 5. Now, a few of you just stop there. You're not done until you get the ordered pair that works for both of them. So now you take either equation, x minus 2y equals 1, or 3x plus 2y equals 19. I don't need you to do both of them. You just need to do one, but they have to give me the same answer. So I take the x out, I put in a 5. I subtract 5 to solve for y, and I get negative 2y equals negative 4. Divide by negative 2, I get y equals 2. All right, now I said that's good enough, but let's just see what happens in here. What's 3 times 5? 3 times 5 is 15. Okay. Preston, what do I need to do there to find y? What do I still need to do? Subtract 15. And then I get 2y equals 19 minus 15, which is 4. And I divide by 2. I still get y equals 2. So my answer is 5, 2. All right, that's the basis for elimination. Okay, that's the basis for elimination. All right, I know you didn't have any homework. Let me actually hand out the guided notes for today, if I can find them.
5'6". No, I'm 5'6". He's 5'8". You're 5'6". Oh yeah. No. So shorter than me. And I'm 5'10". I'm 5'7". So if I slouch, I'm 5'9", which is 69 inches.
Just try.
You didn't even say
Evan. You guys are a little hyped up today. All right, so for this one here,
Yo.
Now, we said they're not all as easy as that first one. That first one was set up perfect. You just add them together. What you got to do is you got to take a look. Will anything, okay, Josh, will anything add up to 0 when you look at these two equations? No, so you don't add them together yet. You don't add them together yet. Rachel, you got any ideas what to do? Was that a big no? That's all right. That's why we get paid lots of money. All right. Any idea what to do, Hanan?
For the top equation, you gotta multiply by 3.
Okay, really close, but you need to change one little thing. One little thing, because if you multiply by 3, that'll give you a 6, and then you get a 6 here. Those don't add up to 0. Multiply by -3. So now you want to take a look is, can I multiply one equation by a number to get something to add up to 0? It doesn't have to be the x's each time. It doesn't have to be the y's. Just something to add up to 0. Now, when you do this, -3 times, you got to multiply every little piece by there. So -3 times 3x is -9x. -3 times 2 is just -6y. And don't forget, you got -3 times 1, which is -3. And now this other one I didn't touch. Okay. All right, now you take a look. You need to have the whole point. Something adds up to 0. And so what do I get when I add those, Christian?
You get -13x equals 40. Wait. Equals 39.
All right, -13x equals 39. Divide by -13. Okay, now I'm not going to say you're never going to get a fraction or decimal, but if you do, you need to double check your work just to make sure that that's right. Now, what is -13 into 39, Jordan?
-3.
-3. So now, I got -3. Connor Hockenberry, how in the heck do I find y?
So you just. Hold on.
Christiana,
Don't you just plug the x value into the other equation?
you plug the x value into one of the other equations. Take your two original equations, pick one. One might be easier than the other, one may not. It doesn't matter, but I'd probably pick the first one just because they look smaller numbers. So you got 3x plus 2y equals 1. So take your x equals -3. That goes in where the x is. So it's 3 times -3 plus 2y equals 1. -9 plus 2y equals 1. All right, finish that. And Zane, let me know what you get. Have you caught up yet? You were just finishing that. All right, Jay Lee, finish that. Tell me what you get. Just the answer for y. What'd you say? So you say 5. Okay, I agree. So you're going to add 9. You get 2y equals 10. Divide by 2. Y equals 5. So always write your answers in ordered pair. -3, 5. If you graph those two lines, all right, Amanda, listen up really closely. Now, if you need the help, you can text Rachel. Okay. If I graph those two lines, would they hit?
Yeah,
Yeah. Where would they hit at?
-35.
They'd hit at negative. You didn't even need to text them. Good. All right. Thank you. And I put the. All right, right. They would hit at -3, 5. Nowhere else. Got it? All right. So you got to tie those two facts together. When we graph them, we found where they hit. When we do elimination, it tells us where they hit. All right. Now, all right. Take a look at those second two. Take a look at those second two. Oh, sorry. Okay, now, there's a little bit of a problem. Nothing we can't overcome. There's a little bit of a problem. What is our problem?
You can't get nothing to 0.
We got, yeah, right now, nothing
Is
will
that,
add up to 0. And now, if I multiply one equation, like the top equation, can I multiply it by anything to get any whole numbers? No. Can I multiply bottom equation? All right, here's the deal. You're allowed to multiply both equations by numbers. We got to do that in this case here. We got to multiply both equations. All right, let me write them down. Jordan, I'll come back to you.
does it have to be the same number?
It does not, good question. It does not have to be the same number. Doesn't matter what, but we just gotta get something to add up to 0. So Jordan, did you have an idea?
Multiply the top by 2 and the bottom by 5.
Okay. Good, that'll work.
Thank you.
That will get rid of the x's because 2 times -5 is -10. 5 times 2 is 10. Did anybody? I'm not gonna mess with it. I don't want to confuse you. Let's just stick with that. All right. So when you multiply everything. Now don't get ahead in case you make a mistake. All right, that first one, multiply that everything by 2 and let me know what you get. Aman, you got that for the first
Try to do
one?
the second one.
We'll go ahead and work on it.
Okay, second one.
10x plus 4y equals 64.
-10x plus, what'd you say?
4y
4y equals. All right, good. Make sure you multiply that 32 by 2 as well. Christian, we got the second.
10x plus 15y equals 50.
All right, I'm just gonna stop and wait. I think we're good. I think we're good there.
64.
Now, add those together. And then think what you need to do to figure out what the y is. Add those together. You got your calculator?
I don't know.
Where's it in your book bag?
I don't know.
Together, what you get together? Okay. Jordan, what you got?
-4, 6.
Oh, you got the whole thing?
Oh.
Okay. So 19y, what's 64 and 50? Is that
114.
14. All right, so now these look a little bit iffy, but what's that give us?
6.
So if it comes out to a whole number, it makes me feel a little bit better. So you got y equals 6. Now we still got to figure out what x is. You can use the equations after you multiply, but it's probably going to be easier to use the ones before. I'm going to use 2x plus 3y equals 10. So I get 2x plus 3y equals 10. I got y equals 6. So that becomes 2x plus 3 times 6 equals 18. Did I do that right? No, it equals 10. 2x plus 18 equals 10. Subtract 18. Looks like I get -4. No, -8. I'm all over the place here. -8 divided by 2. And Jordan, is that what you gave me? -4?
Yeah.
Preston, how do I double check that and make sure I'm right?
You plug it in.
Plug it into the, especially the other equation. You go back to the original problems, you plug in -4, 6. If it works for both of them, you don't need to ask me if it's right. You know it's right. Okay, you know it's right. Okay, if you are confident and you think you can do the third one, go ahead and do it. And if you're not confident, just wait. You're gonna have to multiply both equations. I'm gonna give everybody another minute or two. If you're just waiting, that's fine, just wait.
That was close
We'll
enough.
go through it, just wait.
No. Remove one.
You're not gonna need a number.
Okay, look, you know how to write what this is supposed to be? But here, it doesn't matter because here the x is positive, here y is positive, y is negative. So that's what if we eliminate the y's here, then.
So you can buy back and graph. All right, so now here's what I really want you to think about. Those of you who are kind of, if you're working through it, keep going. But if you're a little bit stuck, if I want to get rid of the x's, now here you can get rid of the x's or y's. I'm going to do it both ways in this case. You only need to do it one way. If I'm going to get rid of the x's, here's one way that will always work. So one is a 2x and one is a -3. Just flip and multiply the, so the top has a 2, you multiply it by whatever the bottom number is. Now, I'm not going to use the negatives yet, so just hold on a second. So that's a 3, I'm going to multiply it by 3, and if there's a 2 here, multiply it by 2. Because 3 times 2 gives me what? 6, and what's 2 times -3? One of them has to, in the end, one of them has to be positive, one of them has to be negative. So you can just use those actual numbers. Now, if you multiply by different numbers, Jordan?
I was gonna say, I multiplied by -3 and -2, would that work still?
They were both negative?
Yes.
Probably not, because -3 times, that would give me -6. Oh, no, that worked.
Okay.
All right, it worked. That worked.
I multiplied by 4 and 5.
That'll work. I'm gonna show you how to do that too. Okay.
I multiplied by them. Does one of them have to be negative?
Okay, one of them doesn't have to be negative here because one of your original numbers is already negative.
Okay, because I
Just in the end. So now when I multiply,
plugged it
I can't.
in.
What was it, 2?
what's 3 times 26? 78?
78.
And now 2 times -3 is -6x. Minus 8.
-75. -75.
Should be -50, shouldn't it?
Oh, yes.
You can multiply that one.
Why does it
Yes.
for 17,000?
So then wait 1 second. Okay, now here's that's a 5. And that's a 5 first. You can just make that a 5 and 4 and a 5. Subtract. So these need to be different sizes. So that, see where that's a plus and that's a minus. They need to be different here. I'm gonna do this your way in the next slide. So don't erase anything. All right, I'm gonna translate. All right, now what do I end up with? 6x minus 6x is 0. 15 minus 8 is 7y. 78 minus 50 is 28. I get y equals 4. Okay? All right. Evan, did you figure out what x is, or did you get y? You got both? Did you get 4? What'd you get for x? Did anybody else get 3 for x? Okay, so now 2x plus 5y equals 26. We said y is 4. That goes in here, so you get 2x plus 5 times 4 equals 26. 2x plus 20. Subtract 20. And I get 2x equals 6. Divide by 2. X equals 3. So if you got 3, 4, you're good. You're fine. Now, Hanan and Christiana multiplied by different numbers. I just want to show you that you only need to do one. That got rid of the x's. So you just have to, in the end, make sure one's positive, one's negative. Now, I forget who said, somebody multiplied them both by negatives. That ended up working. That's okay. Okay, now, take a look. Same, you don't even need to write this down. What would I multiply by to get rid of the y's? Because like, on some of these tests, they're gonna ask you to be like really specific, like what do I multiply by to get rid of the x's? What do I multiply to get rid of the y's? Connor?
You just multiply, the first one, 5 times, 5 times, 4, and then negative 4 times 5.
You can get away. Yep, since that's a 5, you're gonna multiply this one by 5. Since that's a 4, that one's a 4. Since this is a plus and a minus, they're already opposite signs. I don't need to make one of them negative. Now, like what Jordan did on the last one, if you made them both negative, it would still work. But when I do this one, my work's gonna look a little bit different. So 4 times 2 is 8x. 4 times 5 is 20y. And then 4 times 26, what is that, 104? And then 5 times negative 3 is negative 15x. 5 times negative 4 is negative 20y. And then 5 times negative 25 is negative 125. I get a negative 7x. Those add up to 0. And what do I get there? Negative 21. Divide by negative 7. So what do I actually solve for first in this one? I solve for the x. And then when I plug in x is 3, what should I get for y? I should get 4. Does it matter which one you eliminate? No.
Are you recording?
Yeah.
Okay.
Yep. All right, flip it over on the back.
Oh, God. My work phone.
That's your work problem.
And your
I don't care. Give me one pencil.
All right, now what we're gonna have to do is create. Listen up. We gotta create our system. You're not given the system. You're given a scenario, and from the scenario, you come up with a system. It says Paige has $775 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75. How many sheets of each can she buy? She's going to buy a total of 12. It could be 10 and 2, it could be 3 and 9, it could be 4 and 8. That's what we got to figure out. So think about this. If I let F be felt and C be cardstock, one of my equations would be F plus C equals 12. That would be just the total number of sheets. It could be 1 and 11. It could be 6 and 6. Now think about the price. I need to come up with a second equation dealing with the cost of each. How much does each piece of felt cost?
Would it be, like 50 cents F plus like 75 cents C?
What equals what?
12.
Not 12, because that's the number of
Or 7.75.
equals how much the cost she has. So he is correct. This would be our second equation.
On these types of problems, these word problems, you're usually gonna have an equation that looks like that first one, where there's no coefficients, it's just a variable plus a variable to get your a total. More often than not, that's gonna be one of your equations. So the first one deals with just how many sheets of paper we're buying, the second one deals with money.
Zach,
Are we allowed to use like half and 3/4 for this?
you can. More than likely though, in this case, you're probably gonna be better off with the decimal. All right, now we want to use elimination. Will anything add up to 0? Like, because I got my F's lined up, I got my C's lined up, and I got my constants. It's not gonna add up to 0. Jordan?
If you multiply the top by negative 0.5, it'll cancel out the x's.
That would probably be the easiest. So if I take the top one and multiply it by negative 0.5 or 50, same thing. And I only need to multiply the top by that. So it's negative 0.5F minus 0.5C equals negative 6. And now I get positive 0.5F plus 0.75C equals 775. All right, now since we have to deal with like the number of pieces of either felt or cardstock, you have to get a whole number. You cannot get like 2.3. All right, do the next step, add them together. And if you're confident enough, go ahead and keep going and you figure out what the first variable is. Okay. Oh, you got a question on your quiz?
Yeah.
All right, let's just show you. All right, Josh, what did you get? What did you get when you added those?
I got the final answer.
No, just give me the first piece.
I got 0.25C equals 1.75.
Okay, and then what do you get when you divide by 0.25?
I got 7.
Okay, C is 7.
What do you mean negative?
It should not be negative. Just think what we're dealing with.
Oh, shoot.
We're dealing with like the number of pieces of cardstock, the number of pieces of felt. Now, this case here, one equation is clearly easier than the other. F plus C equals 12. Because that's a negative, and this one negative 0.5 plus 0.75. See the negative? That's right. All right, and so F plus C is 12, so that means C is 7. F plus 7 equals 12, subtract 7, and F equals 5. Hey, now in this word problem, you can't list it as an ordered pair because it says how many sheets of each can she buy. For this to work, to get the exact amount at 775, you would buy 5 sheets of felt. And 7 sheets of cardstock. Okay, 5 sheets of felt and 7 sheets of cardstock for that. All right, now, I'm going to give you your homework assignment, but we're going to start. I want you to do at least one together. So pull your book out.
Well, we have to do it like this.
Yes, that's why I want to do one of those together. Okay, for that one. Okay, turn to page 401, and we're going to set up a couple of these if we, based upon the amount of time.
What chapter are you on, 7?
Oh, feel this. My bag is wet.
Hold on to it, so.
Yeah.
What?
All right, are we on the page? Let's set up number 10. And we're going to try and set up 10 and 20 because they're the two with they're the 2 word problems. Okay. So as you take a look at number 10, okay, those are the 2 word problems. Let's see if we can at least get those set up for you. You can put those right at the top. Like you don't need to figure out where they would go in the scheme of the homework. So for 10, it says each family in a neighborhood is contributing $20 worth of food to the neighborhood picnic. The Harlan family is bringing 12 packages of buns. Hamburger buns cost $2 per package. The hot dog buns cost $1.50 per package. How many packages each type? So how many total packages are they bringing? 12. So there's hamburger, which we'll call H, plus hot dog, which we'll call D, equals 12. So H equals hamburger buns.
Hamburger.
Hot dog. Okay, now, what's the other equation? So this is like he said, usually, Mr. Storer said, usually have your first equation has to deal with just variables. So H plus D has to equal 12, so it's 5 and 5, or 5 and 7, or 6 and 6. Now you deal with costs. How much are they spending? Each family is spending how much? They tell you $20. So it has to equal 20, but how much does each hamburger bun, package of hamburger buns cost? $2. So you can just put 2H. How much does each hot dog cost?
$1.50.
$1.50. So $1.50 D equals how much? 20. All right, do me a favor now. Just leave that one and go look at number 20. Okay, leave that problem. Go look at number 20. You got it set up. You can solve it. But now number 20. It's very, very similar. Mrs. Gonzalez bought centerpieces to put on each table at a graduation party. We'll have a bunch of those this year. She spent $31.50. There are 8 tables, each requiring either a candle or vase. So this is not as direct. So basically, how many total candles and vases does she have to buy? 1 for each table. How many tables are there? 8.
60. No.
1 for each table. So the number of candles plus the number of vases has to equal 8. So that's how many total she has to get. 3 and 5, 4 and 4, 2 and 6. I don't know. Now we got to deal. There you go. Now you deal with the cost. How much does each candle cost?
$2.
How much does each vase cost? $4.25. And now in the end, wait, after you're done, what does that have to equal? Equals how much she spent, which was what?
$31.50.
$31.50. Okay. So there's your equation for 10. There's your equation for 20. For all the others, they give you what to do. Okay. So you should be a little bit prepared for those. Okay. So you got those 1, 2, 4 through 10 even, and 19 and 20. 4, 6, 8, 10, 6, 7, 8 problems. 8 problems. Now you can finish 10 and 20 now if you want to, or you can hop up to 1. It doesn't matter. For 10, I would just kind of, if you want to get on the right track, you can multiply the top equation by -2. And for 20, you can multiply the top equation by -3. That'll kind of get you rolling.